Well, hello there! I hope you're having an amazing day and that you have a very strong cup of coffee at your side, because today you're going to need it. Today we are talking about a very essential topic about Rust, and that is scopes. So, of course, our journey is going to start from the basic explanation of the term scope. The scope of a variable, any variable, refers to its visibility inside of our code. So basically, what I mean when I say this is that it basically defines from which parts of the code we can see and refer to that variable, and from which parts of the code we cannot. Okay, that's very nice, but how do you actually define a scope of a variable? Basically, it's very straightforward because it depends on the fact where we have declared a variable, or to be more exact, in which scope it was created. Do not worry, I know that it's difficult to understand this concept without the practical aspect of explanation. So in the next slide we're going to go through some code that I wrote, and I'm going to try to explain how scopes work based on that example. So here is a simple piece of code written in Rust. Of course, do not worry about the syntax, we should not pay any attention to it. We are here just to discuss scopes and nothing more than that. And basically, scopes are defined by curly brackets. I mean, it can sound really simple when you say it like this, but basically it's really true. Every time we have new set of curly brackets in our code, we are basically introducing a new scope. Whether it's a new function, a for loop, or if statement, or just curly brackets without anything around them, we are talking about a new scope. Okay, we can see that in our main function we are just calling the function example that we created under the main function. And inside of this function example function, we can see that there is, again, not much happening, it's pretty straightforward. We are sending a single parameter to this function of ours, and we can see that right after we enter the function, we are just printing the value of this parameter we sent to it. And right after that, we have a new scope created. You can see curly brackets, right? And inside of those curly brackets, we can see that something weird is happening. We can see that inside of these new curly brackets, or inside of a new scope that we created inside of our function, we are creating a new variable that is called or identified with exactly the same identifier as the one that we sent as a parameter to this function. Again, we have param function parameter, which is sent to this function from the main function, and also we are creating a new variable inside of this new scope of ours that's called exactly the same, param. And to get a better understanding what's actually happening, we added another print here. We are going to print param variable again. And after that, we are just closing this new scope of ours, and we are just adding another print of the param variable once again. I think this is a very nice moment to have a simple exercise. Pause the video and please try writing down exactly what you think you're going to get as a result of each of these three printlns. I'm going to wait here for a couple of seconds, and then we are going to continue our discussion. 3, 2, 1, go! Are you done? Okay, let's see how well you did. In the first print line, I'm pretty certain that you were able to guess correctly what was printed, because we are just printing the parameter that was sent. And the result there is going to be 4. Now, the second println is getting a bit more interesting. What do you think was printed? If you said 35, you were right, because that's what we assigned to our new param variable here. And now, finally, what do you think was printed in the third line? I hope you thought it was 4. But even if you got all 3 answers wrong, do not worry, because things can really be confusing when it comes to scopes in almost any programming language, Rust included. Why did we not get 35 again? Because 35 is the last value that we assigned to param variable. Isn't that right? Well, no, because the param variable that we created inside of our function, inside of our extended new scope, does not exist at the moment of execution of the third println. That's why it cannot be printed. Wait, what? It doesn't exist? I know that this might seem very confusing at the moment, but do not worry about it. I'm going to try and explain everything that is happening under the hood of our Rust compiler. You better start making some sense very soon, or else... Okay, to explain this, let's jump right to our drawing board. But this time with a twist. This time our board is going to be placed in the forest. I've heard that forest environment is very good for learning Rust. I don't know if you read this scientific paper, but let's try it out. Hello there! I hope that you're doing great! I wanted to check this statement that learning Rust is the best in the wilderness. I was very skeptical about that concept, so I wanted to check it in practice. Let's do it together, what do you say? Of course! That is only unless we freeze to death before we manage to figure that out. I hope, sincerely hope, that that will not happen. Okay, now I think is the great moment to start the actual discussion. So, our first thing here, let's mention our board. On the board, we've printed everything that we were working on in our Visual Studio Code in enclosed environment. As you can see, I just put the main function under our function example for simplicity's sake, because we're not going to use main function very often. So we want this part of the code to be more manageable and more reachable. And you can see that I added the results that were printed in our println statements in our Visual Studio Code just as a reminder. And also, I think that it's very important to have this, I don't know if you can see it, it's right here, the stack memory. Okay, it's time to start executing our code, but manually. So, the first thing that is going to happen is our compiler is going to start from the entry point into every program, and that is our main function, and it's going to figure out how much memory it needs to allocate for it. And in our case, we are not going to cover the amount of memory it's going to allocate for the main function, because it contains some pieces of data that it needs that are not regular, so to say. And we are not going to cover that because it's an advanced topic. For now, we are going to say that it just allocates a piece of memory for the main function. Our main focus is going to be on the function example and the scopes. That's why we add just a generic piece of memory allocated for our main function. So if you remember, stack memory is LIFO memory, which is last in, first out, which means that because of the fact that main function is the first thing that gets executed, it's the first thing that gets its memory allocated. So our compiler is going to figure out an amount of memory it needs to allocate for our main function and then just allocate it. So let's do it. We need to fight the nature in order to be able to work here. Let's move this around. And now, we have this piece of memory right here, which is going to be for our main function. And here is the block of memory that's allocated for our main function. Now, let's get to the fun part, and that is, we're going to figure out how much memory we need to allocate for our function example. To do that, we're going to start from the top and do exactly what compiler would do. And that is to figure out how much memory it actually needs to allocate for it. So, let's start from the top. We have the parameter variable, which is 32 bits long. So we know that we have a single variable for now. And we continue to the second line, and this line here is just a print. It does not require any memory. So now we came to the point where we are going to have another scope of memory. And for it, we are going to instantiate completely new and independable part in our memory space. So after that, we have only another println, which does not require any memory. So let's draw this part of memory.
A few moments later.
Okay, let me explain what happened in our memory. The first thing is we have created this whole block of memory, which is allocated for our function example. And inside of it, we have this parameter variable, which is this one right here. And also we have this new scope of memory, which is going to be this right here. And inside of that scope of memory, we have another variable called param that is inside of it. We have created our entire memory stack right here. So I feel that it is great time right now to show you at which points in memory we are basically calling our prints. Because if we understand at which point in memory, at which state of memory we are calling our print lines, we are going to be able to figure out why we get the result that we are getting. So let's start from the top. And to make things easier to track, I'm going to assign a number to each of these printlns. So this one is going to be number 1. This one is going to be number 2. And this one is going to be number 3. And now, for the number 1, we are going to call it right after we have entered the function example and after we have allocated a memory for our parameter variable. So basically, we are inside of our function example, and then right after we have created our parameter variable. Something like this, right here. Is that okay? Let's go to the second println. So, the second println is inside of our new scope, and again, it's right after we have created the variable param. So here is our new scope, and here is our param variable number 2, so to say, and right under it, we are going to add the second println. So right here. And finally, the third one, the most complicated one, the one that's bothering us the most, let's figure out where it is happening. So, right here, we are going to try to deduct where we are supposed to be putting it. So, we know that it is after the first one and after the new scope and after everything, but before we have ended our function example function. So basically, it is going to be below the parameter variable, below the new scope, but before we have closed the function example. So basically something like this right here. So under the new scope, but before the end of function example scope. So it's right there. And now, when we have done this, we can actually start figuring out why we get the results that we are getting. Okay, let's go one at a time. The first println is right here. So how do we get the result 4? Well, if you take a look at it and think about it, at the moment of its execution, we only have this part right here. And when we try to invoke param variable, our compiler is going to start searching for it from that point upwards, because this, at this moment right here, does not exist. We still do not have this part right here. So basically, there is only one option, and that is this right here, which is this right here, and which is this right here. So we get 4. I hope that this is logical and it makes sense. Okay, let's go to the second println. So, the second one is a bit more complicated, but still not too complicated to explain. So what is happening? We have completed this part right here, and we have allocated the memory for the new scope, and inside of it we have created another param variable, and we allocated some space for it. But right after that, we are calling our print. So what is going to happen? Our compiler is again going to start going outwards, is going to go backwards in time, so to say, and start searching for the param variable. And when it starts doing that, this right here is the first result it's going to find. So it is never going to reach this one because it always finds this one first. So basically, why would it search for another result if it already found the one that is valid, that completely complies with the stuff that we wanted to get, right? As stated here, we are going to print this one right here, and that one is 35. So I hope that makes sense. And now, the final and most difficult one to explain is the third println. Breaking news! Sorry for interrupting your nature show in Rust, but we have to cover a basic concept. Rustin Forces right. Or resource acquisition is initialization. Before you freak out and get really mad at me, just give me a second here to explain stuff a bit better. It's not as complicated as it sounds. We will not go too deep here, because we do not have to do it, but you need to understand the basic concept that is hiding behind this abbreviation. This concept basically means that every time a variable goes out of scope, its destructor gets called. And now let's cover destructor term. So if you're coming from basically any object-oriented programming language background, you can already be familiar with the concept of destructors. Destructors are pieces of code that are being called every time that a variable or object or whatever needs to be freed because it's not used anymore. Its destructor is being called, so our resources are getting freed and available for future use. Of course, the story is very similar to this one in Rust as well. In Rust, we have a trait that is called drop. And this trait has a single method that is of significant importance to us, and that is drop method. And this drop method is being called on our data every time it goes out of scope. Or basically anytime we want to invoke it manually and be explicit about our data freeing process. Of course, you should have in mind that traits are still not covered topic here, and I know that you are not aware of this concept probably, but do not worry because we are going to cover it in depth in our future videos, so stay tuned for it. Now that we know what RAI and destructors are, I think it's a good time to go back to our drawing board. Welcome back to your favorite nature show with Marco! I hope that you missed me a lot and that you are ready to figure out the third and final println line. Let's do it! So, what is happening here? We can see that the third println is outside of the new scope. So basically, the new scope is done with. We do not use it for anything else. All the code that was inside of it was executed, and drop method can be called on all the data that was stored inside of it. Let us deallocate this memory and make it available for the future use. And to do that, we are just going to cross out this part right here, because as we stated, we do not need it. It's deallocated. And right now, if we take a look at the third println, it's not going to be so difficult to figure out what's going to be printed. We're going to do exactly the same thing. Compiler is again going to search for the param variable, and it's going to start searching upwards. But right now, this variable right here is not allocated, it is deallocated. If you remember, we called its destructor and it's gone for good, so we cannot find it. And the first one that we are going to stumble upon is going to be this one. So that is why we are going to get a result of 4, which is what we expected. Marco, can you hear me? Hello, Marco, I can hear you, but barely. I hope that nature show was nice. Okay, right now I feel like you have enough information to make a decision on your own if you prefer learning from nature or from the enclosed environment. Okay, let's get serious here for a second. This was like enough joking around. I hope that you managed to understand everything that was covered in this video, because this concept is very important and you will have to understand it thoroughly if you want to continue to grow with Rust programming language. Also, have in mind that our next video is going to be dedicated to variable shadowing, another very essential topic, another very essential concept of Rust. But after that, we are going to come back to scopes and extend our knowledge a little bit further. So things can only get better from here. So right now, I would like to thank you for watching this video, and I hope that you enjoyed it nearly as much as I did filming it. And if you did, I would like to ask you a favor again. If you wouldn't mind, I would really appreciate if you could subscribe to this channel and like this video, because that would really help out me and the video channel together. And yeah, thank you in advance for that. And now there is only one thing left. I wish you an amazing day. Goodbye.